The coldest planet in our solar system is Neptune, which is the 8th planet from the Sun. Its average temperature is about -214 degrees Celsius, -353 degrees Fahrenheit. Neptune is also the farthest planet from the Sun, and its frigid temperatures are due to its distance from the Sun and its composition, which includes a large amount of methane gas in its atmosphere. Our solar system is full of incredible and fascinating celestial bodies, each with its own unique characteristics and features. Among these, one of the most intriguing questions has always been which planet is the coldest? In this documentary, we will explore the answer to this question and learn more about the planet that holds this record. The answer to this question is Neptune, the 8th and farthest planet from the Sun. Neptune is a gas giant, similar in size and composition to its neighbor Uranus. However, it is much colder than Uranus, with an average temperature of about -214 degrees Celsius, -353 degrees Fahrenheit. This makes it the coldest planet in our solar system. So what makes Neptune so cold? There are several factors at play. Firstly, Neptune is located very far from the Sun, about 2.8 billion miles away. This means that it receives very little heat or energy from the Sun and therefore remains incredibly cold. Additionally, Neptune's atmosphere is made up of mostly hydrogen and helium with traces of methane. Methane is a potent greenhouse gas, meaning that it absorbs and traps heat from the Sun. However, at Neptune's distance from the Sun, this greenhouse effect is not enough to counteract the planet's extreme cold. Another factor that contributes to Neptune's low temperatures is its internal heat. Like all planets, Neptune was formed from a cloud of gas and dust that collapsed in on itself under the force of gravity. As this cloud compressed, it released heat, which contributed to the high temperatures that existed in the early solar system. However, over time this heat has dissipated, and today Neptune is much colder than it was billions of years ago. Despite its frigid temperatures, Neptune is a fascinating and complex planet. It has a thick atmosphere, with swirling storms and high winds that can reach speeds of over 1,000 miles per hour. The planet also has a system of faint rings and 14 known moons, the largest of which is named Triton. Triton is of particular interest to scientists because it is one of the coldest objects in our solar system, with a surface temperature of about -235 degrees Celsius, -391 degrees Fahrenheit. It is also unique in that it orbits Neptune in a retrograde direction, meaning that it moves in the opposite direction to Neptune's rotation. This suggests that Triton may have been captured by Neptune's gravity rather than formed alongside it. In addition to its moons, Neptune is also home to a series of dark spots similar to Jupiter's Great Red Spot. These spots are believed to be storms in the planet's atmosphere, created by high-pressure systems that cause gases to rise and fall in a circular motion. In conclusion, Neptune is the coldest planet in our solar system, with an average temperature of -214 degrees Celsius. Its frigid temperatures are due to a combination of factors, including its distance from the Sun, its composition, and the dissipation of its internal heat over time. Despite its extreme cold, Neptune is a fascinating and complex planet with a system of rings, moons, and storms that continue to captivate and intrigue scientists and astronomers around the world. The study of Neptune and its moons has been a subject of interest for many years. In 1989, NASA's Voyager 2 spacecraft flew by Neptune and provided the first close-up images of the planet and its moons. Since then, other spacecraft, including the Hubble Space Telescope, have continued to study Neptune and its moons, providing new insights and discoveries. One of the most interesting discoveries about Neptune is the presence of methane in its atmosphere. This gas gives the planet its distinctive blue color and plays an important role in its weather patterns. Methane is also believed to have played a role in the formation of the planet's moons, including Triton. Triton is of particular interest to scientists because it may have once been a dwarf planet that was captured by Neptune's gravity. Its surface is covered in a thick layer of nitrogen ice, and it has geysers that shoot jets of nitrogen gas and dust into the air. Scientists believe that Triton's surface may be the result of a global resurfacing event, which may have been triggered by a collision with another object. Despite the extreme cold of Neptune and its moons, there is still a possibility that life could exist there. One of the key requirements for life is the presence of liquid water. And while the temperatures on Neptune are far too cold for liquid water to exist, it is possible that some of the moons of Neptune may have subsurface oceans of liquid water. In recent years, there have been plans for future missions to explore Neptune and its moons in more detail. These missions would involve sending spacecraft to orbit Neptune, study its atmosphere, and explore its moons in more detail, including the possibility of landing on Triton. In conclusion, Neptune is a fascinating and complex planet, and its extreme cold temperatures make it unique among the planets in our solar system. Its atmosphere, moons, and rings provide a wealth of opportunities for scientists to learn more about the formation and evolution of our solar system. As we continue to study Neptune and its moons, we may uncover new insights into the origins of life in the universe and the potential for other habitable worlds beyond our own.